Hello guys. Good day to you all. In this video we are going to learn how to tune time-taking SQL queries. One of the primary responsibilities of a DBA is to ensure databases operate smoothly and efficiently. We will learn how to use SQL Tuning Advisor to tune queries. Here we go. Let us begin with the reasons why tuning a query is so important. One of the core responsibility of a DBA is to ensure efficiently running SQL queries for the users. A single time-taking query can slow down the entire database by consuming most of the system resources in terms of CPU and memory. Performance tuning is an ongoing activity, and on an average database administrators spend almost 60% of their time tuning the Oracle instance or statements. Tuning is also an art. From many available options, you have to select the most appropriate by studying the execution plan. In this tutorial we will highlight some of the tuning options, but will specifically look at Oracle Tuning Advisor in depth. Some of the basic tuning options available in Oracle database are: create missing indexes. Creating appropriate index on required columns can enhance query the performance. Rebuild of existing indexes. Due to extensive DML, index may require rebuild to perform well. Update schema or objects statistics. If stats are out of date, the CBO might use wrong index, resulting in poor performance. Monitor and minimize wait events. Minimize the waits as much as possible. Monitor locked session and locked objects. Locks can halt the application. There are ways to control locks. Some deadlocks may require session kill. Review execution plan. Reviewing the execution plan may help to identify and resolve the time-taking areas of the query. Rewrite query. In few cases when nothing works, you may give to rewrite your query to improve execution time. Tuning using SQL Tuning Advisor. SQL Tuning Advisor, which is the main topic today, is an expert tuning system that helps to resolve performance issues in a quite efficient manner. To use SQL Tuning Advisor, you need to purchase diagnostic and tuning packs, which are an extra cost option. You have to pass a SQL statement to the Tuning Advisor, and in return it will generate a report consisting suggestions and advices on how to tune the query to perform better. Now the question is how to identify long-running query. Long-running queries need to be monitored time to time, and a proactive approach is required to fix them before getting complaints from the users. Querying $session_longops view provides you the details of such queries. The query below joins $session longops and $session to procedure the desired result. Output is shown in the next screen. The output shows a long-running query selecting data from a table. It also tells the start time, time remaining in seconds, and the overall percentage of the progress. Objective here is to get SQL ID, which will be then passed to Tuning Advisor for execution analysis. Built-in DBMS_SQLTune package is the interface for tuning SQL queries. The package provides three major sub-programs which need to be called in a sequence. The first step is to create a SQL tuning task. Second is to execute the task, and third is to get report. We will start with the first step. Creating a tuning task. There are three ways of supplying a query to tuning task, which are: from the cursor cache, from AWR, manually supplying the query. We will cover all three ways in this tutorial. The syntax is the same, with little variation in the parameters. Passing SQL ID using the cursor cache. For this option the query has to be in the cursor cache. We can use this while the query is still running. All the parameters are self-explanatory. Scope can be limited or comprehensive. Name and description can be anything. Passing SQL ID from the AWR. The only change is to supply the starting and ending snap based on which the AWR report was generated. We can also supply the query itself, which is called manual supply. You can see the code in the next screen. In the script we can see a complete SQL statement has been passed to the analyzer. Now the second step in the tuning advisor is to execute the task. Execute_tuning_task is subprogram which analyze the query, and the input here is the task name we gave earlier. Execution time varies, which depends on the complexity of the query. Once the execution is complete, a report will be generated for your review. Now it's time to review the report and implement suggestions and improvements which can be extremely helpful. Report_tuning_task is the sub-procedure to do this. The output of the select statement below is the report. I will copy-paste the important areas of the report in this and the next slides. In the first finding, the suggestion is to use union all instead of union. If the result set remain the same, using union all is going to improve the query. In the suggestion below, accepting the suggested SQL profile will improve the query by almost 100%. As my personal experience, this helps a lot. Run the execute statement to accept the new plan. SQL profile helps the optimizer to select a better execution plan by providing additional statistics. In the above findings, basically you are going to swap a bad execution plan with a good execution plan, which is certainly going to improve performance. Advisor may suggest you to create missing indexes. In the suggestion below, by creating the recommended index, query will improve by 98.97%. Depending on the complexity of the query, Tuning Advisor can run for longer periods. At any point you can pause and later resume the execution using the following statements. Interrupt_tuning_task will pause the execution, resume_tuning_task will resume it. This is all about manual Tuning Advisor. Hope it is going to help you as well. Thanks for watching the video. Please like the video and subscribe the channel to appreciate my hard work.